Hi everybody, it's Mr. Oaks. In this video we're going to start talking about scatter plots, specifically how to construct a scatter plot and how to interpret scatter plots. Normally when you're graphing information, what you're used to is plotting the points and then connecting them with a line. Scatter plots, that's not what we do. Really what we're doing is we're just going to plot the points to get an idea of what is the relationship. We're not going to play connect the dots. We're basically going to look at the way the points go on the graph and see what type of relationship they have. Is there a strong relationship? Is there a weak relationship? Is there any relationship at all? So what I have here, I have just a general set of data. It could be anything. Well, basically I have my X and my Y. If we look at the X's, they're going 1, 2, 3, 4, 5, 6, 7. We actually skip 8, 9, 10. The Y's are going 20, 40, 50, and so on. So basically what we're going to do is for each basically set of data, we're going to put a point, and then we're just going to kind of look at them and see, well, is there a connection between these two things, whatever they might be? Height and shoe size, age and IQ, something like that. I don't know, we're just doing the X and Y at this moment. So the first thing I'm looking at, 120. So I go here, here's 120. So there's my first point there. Then we got 240. 350, 460, 5, make sure I'm actually on the right one, 70, I'm actually going to move to the side so I might disappear for a second. Then we got 680, we have 780, then we have 720, 980, and 1080. So there we go. We've graphed our points. And what we'll notice is that in this case we can actually have more than an input, have more than one output. Scatter plots don't necessarily have to be functions. They're just a representation of whatever data we've been given. So looking at this, there's a couple of things I notice. One, if I'm looking at most of the data, it's going up. That's what's called a positive correlation or positive relationship. And correlation is basically how is it that the input is somehow affected by the output. Is it affected in a positive way, meaning that as our X goes up, so does our Y? Or is it a negative correlation? As our X goes up, the Y goes down. So those are two of the correlations we can have. We also have what's called and now I just blanked on what I was about to say. Oh, the strength of the correlation. We can have a strong correlation or a weak correlation. A strong correlation basically means that the points come very close to being a line, basically being on the same line. They're not very spread out. They're very close together, forming a straight line. And when I look at these points here, this is a pretty strong correlation, really up till you get about here. This is a relatively strong linear correlation. It's a strong, positive, linear correlation. It's strong because they seem to be making a very consistent straight line up until you get up there. They're linear because it kind of can use a straight line to represent these. And it's a positive correlation because as it's going up, in the x values, it's also going up in the y values. There's a couple of things we have here, though, that we want to discuss. The first thing is this random guy over here doesn't fit the rest of the data. That guy right there is known as an outlier. Basically, it's a point or some points that don't kind of fit the general trend of the rest of the data. So as we look, the data, as we went to the right, it increased in the y values. This one randomly went down. Don't know why. And if we took it out, we still have our positive, strong, linear correlation there. The second thing is we have a cluster. Now, a cluster could be basically the entire group of data showing that it's kind of close together and going in the same direction. But I'm kind of looking at this group up here. Okay? And they're a cluster because they're relatively close together. They're kind of near each other. And so that's called a cluster. The last thing is all this empty space here. It's called a gap. Gap is just where there's no data. Okay? So again, when we look at this, I see that this data has a positive correlation. It is a strong correlation. And for me, overall, it's a linear correlation. And really, I would say strong, positive, linear correlation. I might have put these in the wrong order, but that's what we got. And for those of you who want to know how to spell it, correlation. Okay. I'm very happy I wrote that correctly the first time. Gets a little nervous when I write things like that. So here we have a strong, positive, linear correlation. Going up, I could draw a line if I wanted to represent this data. Here's another one. We use the red for the dots this time. Again, just a general set of data. I don't know really what it is representing. I'm just going to put the points. This time across the top we're going by tens, and across the bottom we're going by tens as well. So both our x and our y's are going by tens. So it's starting off, okay, I got 10, 70, there. I also have 10, 80, 30, 40, 30, 40, and 30, 50, 40, 30, 60, 20, 70, 10, 70, 20, 80, 10, and 120. Knocking over the wall hanging that I always take down to do this. So now I look at this and I notice that as we move to the right, the data is moving down. So this time it's a negative correlation because it's angling down. Okay? And again, it's a relatively strong correlation. It's pretty much, I could draw a line here and it's going to be pretty close. Okay? So again, in this case, I could say that this is a strong negative, and again, I'm going to say linear correlation. I already wrote that word, and it's still, as I'm writing it, I'm going, please don't mess this up, please don't mess this up, please don't mess this up. But, and again, when we look at this, I don't see any real outliers. You might be able to make the argument for this one, but overall, I would call this a cluster. All right, we have a cluster kind of between x equals 60 and x equals 100, all clustered around kind of like a 10 and 20. So kind of have this area where it's a very, where a lot of data kind of winds up being. So again, I look at this, oh, it's going down. As the x increases, the y is decreasing, negative correlation. Now, this last graph, you'll notice no table. Just because I want to show, we've talked about a positive correlation where it goes up as we go to the right, a negative correlation which comes down as we go to the right, and then there's just no correlation. And we can have this show up a couple of ways. One of the ways is it could just literally be that, over here, over there, over there, over there, over there, over there, over there. So the dots are all over the place. There's no, I couldn't draw a line for this if I wanted to. Okay? So that's the one thing. It could be this just random scattershot thing going on. I could also, and I'm going to see if I can make this work with different colors, I could also have it where they make a shape, but it's not a line. So here I'm making kind of a rectangle, okay? There's no real correlation there. Yeah, they make this nice box, but I can't, as the x increases, does the y decrease, or does the y increase? I don't know. I can't tell it. There's no relation. Okay? So that's kind of what we could have there as well. Basically, if it makes a shape other than a straight line, you kind of don't have a linear correlation. You could have a nonlinear correlation where we have it curve, but most of the time in 8th grade, which is what I teach, we're dealing with linear correlation, and if it makes a pretty picture, it doesn't necessarily mean there's any actual relationship. The last thing I want to do, and I'm actually just going to bring this up a little bit, is I'm going to draw two small graphs here, and I'm going to have them both represent a positive correlation, but one is going to be a strong correlation and one is going to be a weak correlation. So a strong correlation, I could have something like that, where I can obviously see, I should actually make these a little bigger. I can obviously see that they're very close together, that I'm getting really close to having a line, being able to have like just one line that represents all the points that I have there. A weak correlation is going to be a little bit more spread out. So I can still kind of tell that they're going up. And again, I want to make this a little darker. I can still tell that the data is increasing as I go from left to right, but it's getting more spread out. So maybe I have fewer points. Maybe it's just that it's really spread out, but I can still tell it's moving in this one direction. But here, strong correlation. Here, weaker correlation. I hope this video was helpful. I'm gonna be doing a number of videos on scatter plots, basically bivariate data, and its relationship and how we can even write a line to represent the data. And I'll be doing that in future videos, which, if you like and subscribe, you'll get a notification. I hope this video was helpful. Just keep at this stuff. You know, you just got to find the patterns, and when you do, it's going to be that much easier. I'm Mr. Oaks, and you have a good day.